All right, let's talk about Solidity. This is the language, the actual blueprint, that powers the entire world of smart contracts on Ethereum and so many other blockchains.
I mean, really think about that for a second. In our world, contracts rely on trust. Trust in lawyers, courts, banks, a whole system of people. But in the digital world, how do you create an agreement that doesn't just rely on trust, but is literally self-enforcing and unbreakable?
Well, the answer is as elegant as it is powerful. You don't just write down the rules on a piece of paper. You program them directly into the system itself. You build it with code.
And that system is what we call a smart contract. Think of it like a superpowered vending machine. You put in the crypto, the code automatically checks that the conditions are met, and bam, the service is delivered. No middleman, no disputes. And the primary language that makes all of this possible? That's Solidity.
So why was Solidity even created? What problem was so big that it needed its own language? It was designed to do something incredibly difficult. Create applications that you can trust to run exactly as promised on a decentralized network with no one in charge and no single point of failure.
Now, it's not the only language for the Ethereum virtual machine, or EVM. You've got others like Viper, which feels a lot like Python. But let's be honest, Solidity is the undisputed king of the hill. It's the most mature, it has a massive community of developers, and the best tools and support, making it the go-to standard.
You know, the best way to understand a language isn't just to talk about it, it's to actually see it work. So let's take a look at our very first super simple smart contract.
And here it is. Okay, I know, looking at code can feel a little intense, but stick with me, this is actually pretty straightforward. It's the classic Hello World program just built for the blockchain. Its only job is to say hello. Let's break it down line by line.
This very first line, the pragma line, is super important for safety. It's basically telling the computer, hey, only use this specific version of the Solidity rulebook to run this code. This prevents a future update from accidentally breaking your contract. It locks in the rules of the game.
Next, you see the contract keyword. You can think of this as the main container, the big box that holds all of our code. For anyone who's programmed before, it's very similar to a class. Everything that defines our agreement lives right inside these curly braces.
And finally, we have the function. This is the action part, the verb. It's the piece of the contract that actually does something when it's called. In this case, our little Hello World function's only job in life is to return that famous phrase, Hello World.
Okay, so we've seen a simple example. Now let's get into the real building blocks, the Lego pieces, if you will, that let us build much, much bigger things.
Now, this is an absolutely critical concept in Solidity. Data gets handled in two different ways. You have value types, like a simple true, false, or a number. When you use them, you're always working with a fresh, independent copy. Then you have reference types, like a list of items. With these, you're passing around a pointer to the original data. Understanding this difference is key to writing code that's safe and efficient.
One of the most powerful reference types you'll use is a mapping. Seriously, if you've ever used a dictionary in Python, you already get this. It's just a way to store data by linking a unique key to a specific value.
And here is the perfect example of why that's so useful. With just one line, we're creating a public ledger of balances. The mapping links an Ethereum address, that's the key, to a number, which is the value representing their balance. This super simple structure is the core of how things like crypto tokens work.
But what if you need to group a bunch of different kinds of information together? Like for a user, you need their name, their ID number, and their balance all in one package. For that, Solidity gives us structs.
See how this struct example works? It bundles together a list, a number, and even another mapping all into one clean custom data type. This lets you organize really complex information in a structured way, which is absolutely essential for any serious application.
All right, let's zoom back out. We've seen the building blocks. Now let's see how they come together to form a complete and, more importantly, a secure contract.
A well-built contract has a few key ingredients. You've got your state variables, that's the data that's stored permanently on the blockchain. You have your functions, which are the actions. You can have your custom data types with structs. And then you've got events, which are like log messages, and modifiers, which are reusable safety checks for your functions.
So what happens when someone just sends money to a contract without telling it what to do? This flowchart shows the logic. This system is smart. It doesn't crash. It looks for special receive or fallback functions. It's a critical safety net that ensures the contract knows how to handle unexpected payments or calls gracefully.
And speaking of safety, Solidity has these incredible built-in tools.
Think of require insert as the bouncer at a club. It checks your ID at the door. Are you the owner of this account? Do you have enough funds? If the answer is no, the whole transaction is rejected. Assert, on the other hand, is like an internal fire alarm. It checks for things that should be mathematically impossible. If an assert ever fails, it means something is deeply wrong with the code itself.
We've been pretty deep in the technical details, but let's pull all the way back up. What is the big picture here? Why does Solidity actually matter so much?
You know, this quote from our source material just nails it. It's not just a program on some company's server. It's a self-contained little packet of logic and data that has its own address, its own home, on the blockchain, living there forever, controlled by no one.
And that, right there, is the ultimate takeaway. Solidity is so much more than a programming language. It's a tool for turning trust itself into code. It creates a new kind of agreement that's transparent, automated, and doesn't require a middleman, because the code is the middleman. This is how you build the architecture of digital trust.
From finance and gaming to supply chains and digital identity, the possibilities are just mind-boggling. So the only question left is, now that you know the blueprint for building trust, what would you build?